This is Algebra 2. This is the second day of quadratic formula. This time we're actually going to solve. We're not just going to focus on the discriminant. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. We focused yesterday just on the part under the radical, the discriminant. Remember, if it's positive, you'll have two real roots. If it's 0, you'll have one real root. And if it's negative, you'll have two imaginary answers. We're going to use that. We're going to predict what the answers are going to be. Then we're going to use that, put it into the rest of the formula, and actually get an answer. So you have to start by figuring out what A is. A is 1. B is negative 8. C is 16. So take those numbers, find your discriminant. I got that the discriminant is 0, which means I'm going to have one real root. So now going with the rest of the formula, negative b. That means come over here, find your b value, and use the opposite sign. So it's actually a positive 8, plus or minus the square root of 0, because that was my discriminant, all over 2 times a, which is 1. So I know that the square root of 0 is 0. So 8 plus or minus 0 over 2 times 1 is 2. 0 is actually going to make no change. So it's 8 over 2, which is 4. I was supposed to have one real root. I have one real root. A is 5. B is 0 because there is no x term. C is equal to 42. Find my discriminant. My discriminant is negative 840. Make sure you put 0 squared minus 4 times 5 times 42. I know that b is 0, but you still got to use it or it messes up your sign. So this tells me that I'm going to have two imaginary. So negative b means 0 because you can't change the sign, plus or minus the square root of negative 840 all over 2 times 5. Check and see if 840 is a perfect square. It's not, so I'm going to have to factor tree it. I know it divides by 10. 10 and 84. That 10 will go down to 2 and 5. 84 will go down to 2 and 42. 42 becomes 2 and 21. And 21 becomes 3 and 7. So I can pull out one pair of 2's. And that's it. So 0 plus or minus, I pulled out a 2. It was a negative, so I pull out an I. Square root of, you got to take 5 times 2 times 3 times 7. 210. All over 2 times 5 is 10. 0 is not necessary, but you need to realize that your 2 and your 10 will cancel. So it becomes plus or minus I, square root of 210, all over 5. 2 imaginary. Imaginary means there's an I. I've got it. The way I get 2 is I do it once with positive and once with negative. So I do have two imaginary answers. A is 1. B is negative 5. C is negative 50. Find your discriminant. My discriminant is 225. It's positive. So 2 real. Negative b means positive 5 plus or minus the square root of 225 all over 2 times 1. Check 225. It is a perfect square, so it becomes 5 plus or minus 15 all over 2 times 1 is 2. Since I took the square root of 225 and figured out that it was 15, there is no square root left. Okay, there's not one. Now, you got to go in here and do it twice, once with the plus and once with the minus. Make sure you press enter before you divide by 2. So 5 plus 15, enter, divided by 2. 10 is one of my answers. 5 minus 15, enter, divided by 2. Negative 5 is the other solution. 2 real roots, 2 real roots. A is 2. B is negative 9. C is positive 8 because that's got to get moved over there. Find your discriminant. I got D equals 17. Positive, so 2 real. Negative b means positive 9, plus or minus the square root of 17, all over 2 times 2. Square root of 17, 17 won't factor, it's prime. So 9 plus or minus square root of 17, all over 2 times 2 is 4. 2 answers because you would do it once with the plus and once with the minus. It's okay to have a square root in your answer. A is 1. B is negative 7. C is negative 18 because it has to get moved. find your discriminant. I got a discriminant of 121, so I'm going to have 2 real. So negative b means 7 plus or minus the square root of 121 all over 2 times 1. 121 is a perfect square, so it is like 7 plus or minus 11 all over 2. So do it once when you add. 7 plus 11, enter, divided by 2, 9. And then do it where you subtract. 7 minus 11 divided by 2, negative 2. B is 1, B is 9, C is negative 11. Find your discriminant. Discriminant is 125. It's positive. 2 real. Negative 9 plus or minus the square root of 125 all over 2 times 1. Check just in case 125 is a perfect square. It's not. Factor tree it. Divides by 5 and 25. 5 and 5. So negative 9 plus or minus 5 square root of 5 all over 2. B is negative 3. B is 4. C is negative 4. Discriminant is negative 32. Going to have 2 imaginary. Negative 4 plus or minus square root of negative 32. 2 times negative 3. Factor tree, 2 and 16. 4 and 4. 2 and 2. 2 and 2. 2 pairs of 2 are going to come out, and that negative. Negative 4 plus or minus 2 times 2 is 4i. Square root of, there's one lonesome 2. All over negative 6. Divide everything by 2. 2 plus or minus 2i square root of 2. All over 3. Negative 3. Change all signs because I don't want a negative in the bottom, which means that becomes a plus and that becomes a plus. When I was canceling and dividing by 2, that square root of 2 is protected. If it's under the square root symbol, you're not going to reduce it. A is 1. B is negative 7. C is negative 1. Find your discriminant. My discriminant is 53. So 2 real. 7 plus or minus the square root of 53 all over 2 times 1, which is 2. So 7 plus or minus the square root of 53 all over 2. 53 is prime and you can't factor tree it. Alright, that's quadratic formula, actually solving it. If you've got questions, come see me during speed.